Hi all, this is a small session which gives you a quick introduction to database systems. So without wasting much time, we can get started. So what do you know about data? Okay, so anything could be a data, like any raw facts. Say if I'm talking back to you, that is data. Whatever you are seeing, this information on the screen, that could be called as data. So data could be, it could be some people, place, or any concepts that you know. And what do you mean by information then? What is the difference between a data and an information? I could say that a processed data is basically called as information. So for this, normally the common example which I used to tell to my students is that, say when you were a kid, just imagine that you were a kid and you were trying to, you are very inquisitive at that particular age. So at that instance, say just imagine that you are in the kitchen and you saw a pot, okay, a hot pot. Maybe your mama is making some tea or coffee or something and she has kept the pot over there, right? And you're just running towards it and you're just touching it, okay? So when you look at this particular scenario, when you look at that particular room, your mother is standing there and she's doing some work in the kitchen, and you could see a lot of vessels there in the kitchen. Okay, so all those things are basically the data which is perceived by you. Okay, so you are actually touching that particular hot pot and it is so hot that your hands get hurt because of the impulse. You have an impulse and you're getting hurt. So now what you have understood as a child is that when the hot is spot and if you touch it, you will get hurt. Okay, so this data has been processed in your mind and now you are getting some information that when the hot is spot and when you touch it, okay, your hands will get hurt. So the data is basically processed now. So this processed data is basically called as an information. Okay, so data management is basically something which focuses on the proper generation, storage and retrieval of data. So whatever you see, whatever you hear, whatever you look around, everything is data. And when you process that particular data, you get information. So we should have proper adequate information for making efficient decisions. So this is a small example which you could see. So you have some survey which is happening. So just imagine that we are in a classroom where you have certain set of girls and boys in the class. But you want to know how many girls and boys are there in the class, just for the information's sake. So you're getting all the data into an Excel sheet and you are sorting it in such a way that you get the information about how many girls and how many boys are there in the class. Okay, so you're making it as a graphical presentation in front of your class so that everybody, maybe a bar chart which helps you to understand that how many girls and how many boys are there. Now coming on to this understanding about what is a traditional file system. So traditional file systems are basically into many types. You know, you have disk file systems, you have the file systems you use in our system. So in the disk file systems, you have basically used the C drive and the D drive and all, right? So in the C drive, basically you use to store all the information which is in the system related information files, and in the D drive you could save the personal files, right? So they're all file mounted. Okay, now when it comes to a normal traditional file system, say you could imagine a department, maybe a university. So in that university you have got a CSE department, civil department, mechanical department, and there is a registry department which basically takes care of the number of the students who enrolls for each of the courses. Say if I'm from the CSA department, I should maintain a separate file for my department, and say the same student is basically enrolled in civil department for one particular elective course. His same information will be there in that department as well. So when you look at this kind of scenario, you could see that the data could be redundant. Okay, and when this particular, say the student A is leaving the college for some other reason from the department, and the CSE department is informed about that he's leaving and the civil department is not informed about, you know, whether he has left or not, what happens is that there will be an inconsistency of data. Okay, so the same data is redundant at both the sides, And if any updation or deletion or insertion happens to the data, you have to manually go and check that this data is basically updated in every single file which is in whichever department it is. So this causes a lot of troubles when it comes to this traditional file systems. And the other major thing which you have to understand is that most of your traditional file systems basically uses the 3GL languages like BASIC, COBOL, Pascal, which is not so, it is more complex for a normal human being, not like your high level languages. So now moving over to what are the major issues of your traditional file systems. You could say that data dependence is one of the major issues. Structural dependence is one of the issues, because I may store in my department, I may store it as a .txt file, you may store it as a PDF file, and in some other department it is stored as an Excel sheet. So it is not compatible, okay? And you have to manually go and check whether the data is updated or not. But in the case of the and data redundancy, of course, because the same kind of data might be stored in multiple places in multiple ways. So this can cause a lot of anomalies. Okay. And now moving over to why do we need a database? So we basically need a database. So we basically need a database so that we can actually avoid such kind of redundancies and eliminate the structural dependence and the data dependence. So the major objectives of any database technology is basically data independence, minimal data redundancy, and the sharing is made easy, the quality is maintained, the security of the data is maintained, and we have a better access to the data, and less maintenance is that what is required, and interrelate data through the model. So we have a model so that we can communicate through all the data which is stored in an easier manner. Okay. So basically what we will do is that we will have a central repository where we store all our data and everybody else can access that particular data. So even if you think about considering the fact that, okay, university, so university has got multiple departments, so all your data related to the student enrollments will be there in the registry. So if you want to deal with, or if you want to access the data from the CSE department, you can go and access the data, and if it is from the civil department, they can go to the central registry where all the data has been stored, and you can access and you can come back. Now moving further, database has got a structure. So the major structure of this database is basically, it is divided into 3 different layers. One is a physical layer, one is a conceptual layer, and finally the presentation layer. So whenever I see this picture, I will always tell people that it is easier for you to remember in such a way that, say, you have mobile phones and you used to install a lot of applications in your mobile phones. So say if I have one particular application stored in my mobile, and I can see, I can have a dark theme, I can have a light theme. So the presentation is basically up to me. How it has to look like, it is basically up to the clients. So in the same way, when you look at a database, say if I'm from the CSE department, how my database has to look in front of me, because I don't require any data related to the civil or department or a mechanical department. I want all the data related to the CSE department. So how the data has to look in front of me is completely up to myself. So that will basically come in the presentation layer or the external layout views. So they are called as views. And now when I'm talking about this physical layer, it basically deals with how the data is stored. Say I have a student relation or a student table. So in that I have got, say, various characteristics like, say, student ID, student name. So I should define, or I should have a clear understanding that the student ID has to be an integer, has to be of integer data type, and student name could be a varchar. So this is the kind of the understanding which I should have at the physical schema level or the physical layer. So in the physical schema, I will be mainly dealing with how basically I could store a particular data in the database. So that will happen at the physical schema. Then comes to this conceptual schema or the conceptual layer. So this is mainly for the mid-management team or the design team. So that means that I will have a clear understanding about what are the various tables that has to be there in a database and how they are related to each other. Say, for example, I have a university database. I have civil department, I have CSE department, I have mechanical department. Say I have 3 different tables for this and how these 3 are basically related to each other. And finally comes the views. So why do we need the structure? So that's a question which arises here. So we require this particular structure for data independence. Say my company is expanding, okay, and my design layer, I'm extending my university by adding multiple courses. So of course the design changes. So when this design changes, this should not affect, or this should not have an immediate effect at the presentation level or the view level. So there is a logical data independence which happens in between. And when and how the data is basically stored. So because many more tables added, and how each and every data actually added into the has to be stored in the database, that basically changes. So this should not have an effect, immediate effect upon this conceptual schema. So there should be a physical data independence. So data independence is one of the major thing which we have to keep in mind when we go for this schema structure which we follow in any DB. So in order to have a clear understanding about how the data is stored at the physical layer, so I have a student table, I have a course table, and in the student table I should have a clear understanding, even at the implementation level, say the first name has to be, the student ID has to be integer, the first name has to be varchar, so all this information has to be stored. And in the case of the logical or the conceptual level, I will be mainly concentrated upon the design. I mean, like how the student is enrolled into a course. Okay, and its own so on and so forth relationships will come in this particular picture. So data dependence, of course, is the property of being able to change the logical or the physical structure of data without requiring changes to the application programs that manipulate that particular data. So this is a simple example for that. Now just moving over to what is basically a database and a database management system. So understand that a database is basically a repository, a centralized repository where you basically store all the data, and database management system basically helps you to query your database for retrieving the relevant data which you have to be. So usually you will have a database administrator who basically helps you to query your database with the help of the structured query languages. So you can use the structured query languages by which you can actually query your database for retrieving the data from the database. And so there are many major functions like the data dictionary. Data dictionary is nothing but metadata. Whatever data you have, all those data about the data will be stored, in fact. So the security management, multi-user control, backup and recovery management, all this information are basically the database management functions, and integrity management, and database language and application programming interfaces, because you might be doing a lot of, or you might be, each of the database might be associated with multiple utility programs through the programming language interfaces. So everything has to run and maintain properly. And now what do you mean by a database schema? So a database schema is basically kind of the structure of your data table which you have created. Say you have a student table, and I'm just giving you the structure. Say in my student table I have student ID, F name, last name, and login, age, and GPA. So these are the information that is there. So if I could take that information alone, that gives you the schema. And this relation or a student table or a student schema, they are all the same. And instances are nothing but the records which are inserted in the real-time instances that basically you are storing inside your database. I mean, like say student table. So you have a student table here. So this John is this row. The first row is basically one of your instance. Second row Karen is one of your second instance. This is the third instance. So these are all called as instances. So now we are moving over to a little bit more like, why do we need database models? Yes. So database models basically is nothing but how you can actually represent your database. Okay, so I can represent the database in different ways, different models. So database models will simply give you a clear idea about what is your data description, what is the kind of the data, the semantics, the meaning, the data that you are going to, content that you are going to store inside your database, and is there any constraints or restrictions that you're going to pass upon your database. So these are the major things which you will keep in mind. So data model defines the data elements and the relationship between the data elements, and how the data is stored, how they are connected, how they are accessed, how they are updated, and everything what happens in the database management system has to be, that is made easy with the help of your different data models. So there are different type of data models which are available. So database models simply help you to design your database and help you to keep your relational tables intact, and help the developers to have a clear understanding about what the data is, how it is basically stored, and is there any missing or redundant data in your database. So in database, so these are the major things you have to keep in mind. So as far as any database is concerned, we have already seen the layered structure, like you have a conceptual model and you have a physical model. So the physical model, you are mainly worried about how the data is stored, and in conceptual or the logical nature basically is nothing but how the data is related to each other. So there are different models which are available, like relational model, semi-structured model, entity relationship model, network model, hierarchical model. So in our course, basically we deal with the relational model, but still there is a hierarchical model, so which will have a main root, and they will have multiple hierarchies which are coming in picture. So that like you have a parent and you have children, and how it is related to each other, and all the structure will be maintained as a tree. And there is network model. So in network model, you can have multiple parents, like how each of them are related to each other, and each of the record will have its own owner, and there will be a member record, and how member can have several owners and all this stuff. And then comes the very famous model, which is the entity relationship model. So in entity relationship model, we basically deal with the entities, relationships, attributes, constraints. So these are the basic building blocks of any database model which you use, whether it is hierarchical, whether it is network, whether it is relational. So these are the basic building blocks, or whether it is ERD itself. So in entity is nothing but, say you have a student database, say you have a student university database, in that you have student and courses. So student can be one of your entity and course can be another entity. And the student can have characteristics like student ID, student first name. So these could be called as the attributes. So attributes are nothing but the characteristics of a particular student table or of a particular entity. And say for the course, you will have a course ID and say the course name. So basically entity is here is the course, and its characteristics, course ID and course name, could be called as the attributes. And say how student may enroll into a course, right? So student can enroll in one or more courses. One course may be associated with one or more students. So these are the relationships. So probably you could say that enroll is basically kind of the relationship. And I'm just having a common scenario or restrictions that each of the entity could have one particular attribute which cannot be repeated. So I could say that, say the student ID is unique. That could be one of your constraints. So these are the four basic things which acts as the basic building blocks of a database model. And yeah, so the course and the school and how it is all related to each other. So this course is an entity, school is an entity, teacher is an entity. The CNAM, TID, SNAM are the attributes, and these teachers is basically called as a relationship. And this is actually underlined. That means that there is a constraint which is imposed on it. That means that CNAM has to be a primary key. SNAM has to be a primary key. TID has to be a primary key. So the constraint which is imposed is that it cannot, it has to be unique, or it cannot repeat. And so the one major thing which you have to keep in mind is that the term cardinality. Cardinality is nothing but the type of the relationship. So it mainly deals with one-to-many relationship, many-to-many relationship, one-to-one relationship. In that we will learn about many-to-many relationship, and it's very important in the relational models. Say, for example, this is kind of a business rule. So an agent can serve many customers, and each customer may be served by only one agent. So there are different type of notations. So one is a Shen notation, and the other one is a Crowfoot notation. So here, if you could see this particular first row, if you take, so a painter can paint many paintings. One painting may be associated with only one painter. So this is the same thing which is actually represented in the Crowfoot notation. So a painter can have one or more painting, and one painting may be related with one and only one painter. So this is how this is basically the cardinality, the representation of the cardinality, and it is actually shown by using, it could be either shown by using the Shen notation or by using the Crowfoot notation. It is called as a Crowfoot because this side, when you see it, it looks like a Crowfoot. And now moving over to this is the representation of the relational model which we are going to learn in our whole course. So in a relational model, each of the table or a relation will be represented in the form of rows and columns. Okay, so you will have multiple rows. Okay, so the horizontal ones are the rows, and you can have columns. Columns are nothing but the vertical ones, and the columns are also called as the attributes, and the rows are called as records, or they are also called as tuple, and this whole thing will be called as a table. And if you see, say just imagine that SID is your primary key. That means that the rule which is posed is that your SID has to be unique. So that means that, say if I take 1101, it can uniquely identify this particular row. That means I will get the whole information of Alex. So if I take 1104, this key will uniquely identify this particular row. That means that 1104 will be only once, it cannot repeat anywhere in your table. So this whole table, if you could see, is the entity or the relation. You can call it as a student entity, you can call it as a student table, you can call it as a student relation. Now each row individually are called as individual tuples, or they can also be called as records, and each column can be called as the characteristics or the attributes. And the constraints are nothing but the rules which are enforced upon the table. That means that, say I want my SID to be unique, so that is one of your primary key constraint. So this SID could also be called as the primary key constraint, because the primary keys uniquely identify each tuple in your student table. Now moving over to there is another concept called foreign key constraint. So just imagine one student is enrolled in a course. Just imagine that he can enroll only in one particular course for the time's sake. So say you have student ID, first name, last name, and you have this course ID and course name. So you have two different tables. One is a student table, one is a course table. Say in order to have a relationship, in order to show the relationship between these two tables, we are going to place this course ID along with the student table. But in the student table, we are not going to place this course name, because the course ID itself is a primary key which is unique. So the student ID, the first student ID, Jim, can only enroll in C002. Okay, and he can enroll only in one course. So this is the course ID is the one which actually acts as the foreign key, because the foreign key is basically the primary key of another table. Okay, so course ID is basically the primary key of this course table, and it is placed as part of your student table. So this course ID is called as the foreign key of the student table, which actually is the primary key of the course table. Now there is something called business rules. So whenever you're given with a scenario, from the scenario you will be able to understand that how the relationship and what are the entities. So you need to identify what are the entities, what are the attributes, what are the relationship, what are the constraints. Say for example, you are given with a business rule. A customer can make many payments, and each payment can be made by only one customer. So that means you clearly know that, okay, I need an entity customer, I need another entity payment. So these are the two different entities which comes to play in this from this particular business rule, and how they are related you will be able to understand by reading it again. I mean, like a customer can make many payments, so it is like a customer, one to many, and each payment is made only by one, and so it is one to one. So this part is one to one and the other part is one to many. So for example, so when you look at this particular example, a customer may generate many invoices. Each invoice is generated by only one customer. So if I'm asking you to identify the entity, what are the entities here? So yes, you have the customer entity and you have the invoice entity. And these are the two different entities here and how they are related to each other. So from customer to the invoice, you have a customer may generate 0 or many invoices. He might not, get anything from your company at all. So, or you can have 0 or many, okay, invoices. And when you look at the opposite side, an invoice is basically generated for only one customer. So this is the kind of the information you can actually get from the business rules. So when you look at this, so a region can have many stores, and the store can have many employees, and one employee might be associated with one job. So this is this particular scenario. For this particular scenario, this is the cases. So this is how it is. So we have basically learned about certain concepts here. What is data? What is information? What is the traditional file systems? What are the disadvantages of traditional file systems? Then we have learned about why do we need database? Yes, we need database to eliminate all the disadvantages of the traditional file systems. And we have also learned about the structure, I mean the different layer of the database systems. Then after that we have learned about what is cardinality and how basically we can actually represent a business rule into from a scenario, how can you identify the business rule and how can you identify the different database models which can be used for representing the databases. So hope you understood this, and please go through the chapters and read the chapter clearly so that you will have great understanding about what it is. Thank you so much.